Hello everyone, we want to continue on the topic of resistivity. We defined two different types of resistivity, the brine resistivity or RW, and also RO, which was the resistivity of a rock which is 100% saturated with water. So if you look at the picture on the bottom right of this slide, you can see RW. So the porosity is mentioned to be 100% because when we measure the RW, we are just measuring the brine resistivity. The water saturation is 100% as well, so it's basically a bucket 100% water filled with water, right? So we measure the resistivity of brine, and that's going to be RW. Now if we add rock, so we use basically the same brine, we fill a rock or saturate it 100% with the same brine, and we measure the resistivity of the rock. This time we pass the current through the rock. So let me show you. In the first case that we are measuring the resistivity of the brine, we pass current through the brine and we measure RW. In the case of RO, we have a rock, we 100% saturated with the same brine, and we pass current through the rock, and the rock might have a porosity of, for example, in this case 20%, right? And we saturate it 100% with the same brine, and we measure the resistivity, and we call it RO. Now what if you have a rock which is the same rock, 20% porosity, but the saturation of the water is not 100%, but for example, it's different. In this case, it's 20%. You can see on this picture. So the rest could be oil and gas, and that's basically what you see in the reservoir. You see a rock which have some porosity, some water saturation, some oil saturation, might be there might be some gas saturation as well, right? So if you pass current through that rock and measure electric current, measure the the resistivity of that rock, we call it actually the true resistivity. Sometimes they call it total resistivity. So RT, and we show it with RT. RT is again the resistivity of a rock which has some water saturation, some oil saturation, and the relationship between all these resistivities are very important to us. For example, the relationship between RW and RO, which we derived it previously, we talked about it through the formation resistivity factor, this equation here. F was equal to RO divided by RW, and through general equation, this was one of the equation, right? The equations that we discussed, the equation that we had, let me show you here. We had these relationships, right? The definition of FR was RO over RW, right? RO divided by, sorry, this is not properly working. Anyway, the definition of FR is basically RO over RW. We had it in previous slides, and this was called Humble formula, right? And the relationship between RO and RT is through another equation, which is called saturation equation, and it's shown at the top. This is the definition. RT is equal to RO multiplied by SW, which is the water saturation to the power of negative n. N is called the saturation exponent. So N is this saturation exponent, and somehow my pen is not working. Anyway, so n is called saturation exponent, and we have this equation. So we have RT is equal to RO multiplied by SW to the power of negative n. On the other hand, we have the relationship between RO and RW. RO over RW is equal to 1 over porosity to the power of n, or in very general sense, this equation was what? A over phi to the power of m, right? Sometime it writes, sometime it doesn't. A to the power of phi m is equal to RO over RW. This is equal to F, and you can see from this equation you can substitute, instead of RO you can substitute RT multiplied by SW to the power of n, right? From this equation. So from that equation, RO is equal to RT SW to the power of n, and this basically is an important equation which is called Archie's equation. We'll discuss it in next slides. Another thing that I need to mention again, you can see an arrow here that shows the resistivity. The brine resistivity is the lowest because it has ions in it. The RO has higher resistivity than RW because you have rock fragments and rock matrix within your system. The rock resistivity is infinite, as we mentioned previously. And finally we have RT, which if you have rock, you have less amount of water, and then you have some oil. The oil resistivity is higher than the water or brine resistivity, and therefore your resistivity increases in this order. So you have RW, then you have RO, then you have RT. Okay, you can see also in this table that the rock have the highest resistivity, then gas, then oil, then fresh water, then salt water. And salt water, because it has ions and cations, anions and cations, basically you have some electric current passing through your brine. All right, so we just mentioned this equation, right? This is saturation equation again. So you can see the saturation equation. That's the same equation we just talked about it in the previous slide. RT is equal to RO multiplied by SW to the power of n, right? So we have this equation, RT is equal to RO multiplied by SW to the power of minus n, and we call this is called the power law model, which relates your resistivities to the saturation. And this is very important. This helps us to if we have the information about the resistivities of the rock, RO or T, then we can measure or we can calculate the water saturation inside our rock. This is very important relationship. How do we do that? This IR that you can see here is called resistivity index. It's mentioned here. It's called resistivity index, and RT is the true resistivity of the rock, right? We just mentioned it in previous slide. Now this is a power law model. What does that mean? So power law model means that if you take the log of each side of the equation, RO is W to the power of minus n, this is equal to what? This is equal to log of RO minus n multiplied by log of SW, right? Using the log equations and relationships. So if you plot, and what else can we do? I should have done that first, but that's okay. I can take the log of RO to the other side. So that would be log of RT minus log of RO. So that's basically log of RT minus log of RO, which I can write it this way, right? Minus n log of SW. So what does it mean? If you plot IR, which is this ratio, this is log of IR actually, right? If you plot on a log-log plot, if you plot IR as function of SW, the slope of that line is N, the saturation exponent, and that defines what type of rock you have. Saturation exponent is a function of the rock type. So you might have different rock types, the saturation exponent would change. Okay, so if you could find the saturation exponent for a specific type of rock, then you can use this equation to find the water saturation for that rock type, depending on whatever oil saturation you might have on the sample, right? So this equation can be used if you know how to find the saturation exponent. This equation can be used to find the water saturation. Now we have this equation. Right? And we basically, if we plot it, that's basically the same plot that you saw in the previous slide. N is the slope of this line, and you can measure it in the laboratory, right? And remember, we derived that equation. F is equal to A over phi, or formation resistivity factor is equal to A over phi to the power of M. M is the saturation. M is called the cementation factor, remember, and RO, RW, right? And if you substitute RO with the equation related to RT and SW, the saturation equation, you can finally get to this important equation. RT is equal to RW A over phi to the power of M multiplied by SW to the power of negative N, right? This is the same equation. That's exactly the same equation, but it's written in terms of water saturation. Okay, so water saturation is N is the saturation exponent, you can see here. A is just a constant, usually close to 1, A, right? Remember the Humble formulas. In that case, A was equal to 0.62 in one of the equations, and in the another equation it was 0.81, right? So it's pretty close to 1. RW brine resistivity, phi is the porosity of the rock, RT is the true resistivity of the formation. So this is very, very, very important equation that helps you to find the water saturation. So in the next video, I'm gonna talk about we're gonna do an example on this.